Assalamu alaikum wa rahmatullahi wa barakatuh. Today we'll be starting a series of lecture about diabetes mellitus. Today we'll be starting with an introduction describing how insulin lowers the blood sugar. For all the natural activities of the human body, for the heart to contract and push blood, for the kidney to work and excrete waste products, for the muscles to move the body, all these organs needs energy. This energy is extracted of the food we are eating every day. The problem here is that foods are given during specific times, our usual 3 meals per day. And the body needs a continuous energy supply the whole time. How this is regulated? Keeping the supply of energy to the body constant all the time in spite of the intake of food or in the fasting state. This is the role of insulin and its counter-regulatory hormones we will be discussing today. The major fuel we are obtaining from diet, usually taken from carbohydrates, from proteins, and from fats. When these foods are oxidized in the tissues of the body, a process what we call the catabolism, energy is released, which is stored in the form of adenosine triphosphate, the main energy source for all body organs. When anyone takes food during the usual meals, usually the amount of food ingested is much more over what is needed at the immediate moment. That's why the excess should be stored in the body for use in between the meals or in the fasting state. This process of fuel stores are done in several areas. In the liver, it is stored mainly as glycogen and also in triacylglycerol or fat. It is stored in the muscle mostly in the form of glycogen and protein, and it is stored in fat in the adipose tissues. Here we can see clearly that in feed state, the excess food ingested is stored in different forms as fat, glycogen, or protein, which will be used later on in the fasting state to maintain the supply of energy to the body. The main purpose of oxidation of the food, as we have said before, is the generation of adenosine triphosphate, which is the main energy storage form which can be used by the tissues. The dissociation of adenosine triphosphate will release energy used by the body different tissues for the performance of all the biological processes occurring all the time. As we can see here, fatty acids, glucose, and amino acids pass to formation of an intermediate component, acetyl coenzyme A, which enters into what we call the tricarboxylic acid cycle, also known as Krebs cycle, for the generation of energy stored in the form of ATP and production of end or waste product as carbon dioxide and water. Here we can see clearly this cycle of energy production with the oxidation of carbohydrates, lipids, and proteins to generate adenosine triphosphate or ATP. On the other side, it is utilized for all the biochemical processes in the body, in different tissues. How is this control of the intake of energy, which in excess of the need of the body and is stored in the different storage area, liver, the muscles, and the adipose tissue, to be used later on between meals and in the fasting state. This is the role of two main hormones, insulin and glucagon. Both of them are secreted from the pancreas. That's why you consider these couple hormones, insulin and glucagon. This is the main control mechanism for maintaining what we call metabolic homeostasis. Since there is a fluctuation in the type of food, we have different roles for insulin and glucagon. To start with, insulin is released from beta cells of the pancreas in response to carbohydrate ingestion and the rise of the blood glucose. Insulin will act to store all the excess of glucose, mainly in the liver in the form of glycogen, in the adipose tissue in the form of fat, a process described as anabolic process, and that's why insulin is considered an anabolic hormone. Here we can see clearly the different forms in which the excess energy is stored. In the liver, glucose under the effect of insulin is stored as glycogen. It can also be stored as fatty acids in the liver, and also for the synthesis of protein, all of which can be used between meals to regenerate the glucose stored before, as we will see later on. In the muscle, it is stored mainly as glycogen and protein, while in adipose tissue, it is stored as a fat or triacylglycerides. Of course, the control of the release of insulin from the beta cells of the pancreas is stimulated by rise of blood glucose immediately after meals. The insulin release reaches its maximum about 30 to 45 minutes and returns back to normal to its basal level 2 hours after the meal. On the other side, glucagon, which maintains the supply of glucose to the tissues in between meals and in the fasting state, it is released from the alpha cells of the pancreas, stimulated by two things, by the decrease in the blood glucose and the decrease in the plasma insulin. Glucagon will work mainly on the liver to generate glucose from the stored glycogen, a process called the glycogenolysis, which means the breakdown of glycogen to glucose, and also the generation or creation of glucose from amino acids, a process called gluconeogenesis, meaning it is production of new glucose from non-carbohydrate source, meaning here the amino acids. It also works on the adipose tissue to induce lipolysis, degradation of the fat in the adipose tissue to fatty acids which can be used for energy production. We can see this in this figure, how this is happening. Glycogen breaking down the glucose, the transformation of amino acids to glucose, the gluconeogenesis. By the way, skeletal muscles is not affected by glucagon since it does not contain receptors for glucagon to act upon, while adipose tissue respond to glucagon release by lipolysis or degradation of fat into fatty acids. Usually in each day, about 190 grams of glucose is required for an adult. Most of it, about 150 grams, is used by the brain, and 40 gram left used by other tissues. A decrease of the blood glucose below 60 milligram per deciliter will decrease the supply of glucose to the brain, resulting in hypoglycemia, we discussed before in other lectures. So we have here a sort of balance between the action of insulin and the glucagon. Insulin works to keep the excess glucose after meals in the form of glycogen, fats, and proteins, while glucagon will maintain the supply of glucose between meals and in the fasting state. We can see clearly here the relation between the glucose level. If after meals the glucose is rising, as you can see here in the upper part of this figure, insulin will rise and help to keep excess glucose in the storage forms we discussed before. And at the same time, glucagon will decrease since there is no need at the time there is excess glucose in the blood. Lastly, in this figure, we can see this cycle of fed and fasting state. On the left side here, we can see that when blood glucose is rising after meals, the pancreas will secrete insulin, which will store the excess glucose in the liver, in the adipose tissues, and in the muscles, and the blood sugar is lowered back to normal. The opposite happens between meals and in the fasting state. With decrease in the blood glucose level and the decrease of the insulin, glucagon is secreted from the alpha cells of the pancreas, which work to maintain the blood glucose level by glycogenolysis, the degradation of glycogen to glucose in the liver, and gluconeogenesis, the generation of new glucose from amino acids in the liver also, so that blood glucose rises back to normal. This balance between the insulin and the glucagon is the main mechanism maintaining homeostasis for glucose all the time. This concludes our discussion for tonight. Coming up lectures, we'll be discussing diabetes mellitus in detail, describing its types, its pathogenesis, how to diagnose, and how to treat. I hope the explanation was clear. If you feel that it was a good lecture for you, don't forget to like it, to share to other colleagues, and to comment. If you did not already subscribe to the channel, don't forget to subscribe and to press the bell button to get notification of all coming up lectures. Thank you very much for your attention. I hope I will be seeing you again in coming up lectures. Wassalamu alaikum wa rahmatullahi wa barakatuh.